hi student, we see you again. So today I will continue our Form 5 lesson. That's a 1.2 resolution of forces. Okay, come, let's see the question. Okay, this is one of the induction. Let's see the diagram. One of the boy is pulling, okay, pulling a trolley. Okay, now we're going to see this part. From here we find it, they got forces to acting by the boy. The one we call it as a pulling force. Okay, they go upwards. Okay, after you pull, you find it, they will move. Okay, where the direction the move? Okay, they will move to the left hand side. So this one we call it the motion of the direction. So that means the pulling force, they were acting to the object. Finally, depends the motion of the object where to go. It's normally they follow the direction of the force. But for this one situation, the direction is an inclined plane. So when there's an inclined plane, that means we need to solve it by resolution forces. Okay, if left and right is okay, we just plus and minus. If up and down, we also say plus and minus. But now the situation, the force there will acting to the object with some certain angle. So come, let's see what we need to continue. Okay, the first one, they say the inclined plane. Okay, inclined plane, they say about the pulling force having a horizontal component and also the vertical component. So from here, we need to create, for the inclined plane, we need to solve it, become the horizontal and also vertical. Then this one finally, that means we can solve by also the resultant force. Okay, let's see the diagram. Okay, first one, the definition for resolution of the forces. There's a process to resolving the force into the two components. So this one is a process for the resolution. Okay, let's see the two components. What is that? Okay, this one is an example. Okay, this one is a force pulling up. Okay, now resolution of the pulling force, that means from the starting point, they're separated by two forces. Okay, we separate, one is go up, the one we call it is a vertical forces. Okay, another one should be the horizontal one. Okay, also from the starting point. So this one we call it as a horizontal component. Okay, let's see the diagram. Okay, now one of the boy, they pull using the rope to pull it, is it? Okay, now the forces should be acting to the upwards. Okay, let's see the diagram. Okay, now the force pull upwards. Okay, because you pull, so the arrow should be up. So from here we need to find out two of the component by this pulling force. So from here we do the resolution of the forces for two components. So one, this one is a starting point. So one should is go up. Okay, another one should be go to the left. So these two components must be cover the pulling force. You cannot say one is go another side. Okay, one is go downwards. No, you must cover the this one is called is an inclined plane, the arrow. So that means finally they will follow this one resultant force, then the object will move forward. Okay, let's see the another two component. Okay, one is move upwards, another one is move to the left hand side. So you can see these two arrow, the component is cover the pulling force. Okay, then we continue with this one, resolution of the pulling force. Okay, now is one of the diagram. The ball is pulled. Okay, now we're going to see they got friction. Okay, when you move just on the ground, that means you got friction. Okay, up, we sure got normal reaction. Okay, the second one should be the weight. Okay, now the normal reaction and also the weight normally become the equal lah, because the ball is never lift up and also go downwards. So that means we find it normal reaction and also weight should be same. Okay, but the problem is the boy now is pulling. So the boy must moving, is it? So that means later, the direction you need to count forward is how many? Then you need to minus the friction. So finally, you can find the resultant force. Okay, come, let's see another diagram. Okay, now when it's just pulling, and you find this one, force should be the incline. So this one incline, that means we need to do the resolution of the forces. Resolution of the forces mean you need to create two of the component. Remember just now we mentioned that two component, one is a fx, one is a fy. Okay, fx we call it as a horizontal component. Okay, function is let the boy to move forward. Okay, another one should be the vertical component. Okay, vertical component, there's a fy, the acting upwards. That one just want to balance the weight. Okay, so this one is a 2 component from the resolution. Okay, now we need to solve the problem. Okay, so from here we're going to see the diagram, same diagram. Okay, the pulling force acting on the boy can be resolved into 2 perpendicular components. So that means later you draw that 2 lines must be perpendicular to each other. Okay, the vertical component is to be balance the weight of the boy. So this one is a function. Normally the question when they just ask you, you resolve for the vertical component, what's the function? So your function should be balance the weight of the boy. How about the horizontal? The horizontal component, actually they want to overcome the friction. Finally, the boy can be moved to the right hand side. So normally the horizontal, they want to make the object to move it. Okay, then the vertical, they just want to balancing the weight. Okay, so this one is a function for the 2 component after resolution. Okay, now we're going to continue to the next part. Okay, a force acting on a small box at an anchor data. Okay, this one example, a pulling force acting to the box. Okay, with the anchor, okay, there's data above the horizontal line. Okay, so now the resolution of the force into 2 components and also the magnitude of the 2 components can be resolved into the component which are perpendicular each other. So now we need to find out the forces, okay, horizontal forces and also the vertical forces for the object. So we need to do the resolution. Okay, one should be go up, okay, another one should be go to the right hand side. So this one's all starting from the original point. Okay, so you can find it Fx and also Fy, they are cover the pulling force. Okay, so from here this one is an anchor, the question already give you, there's a data. So that means from this one situation later, we need to find out what is the Fy, we need to find out what is the Fx, or sometimes you need to find out what is the anchor. Okay, depend the question what they want. Okay, now A horizontal component, there's a Fx. So that means we no need to mention too long already, horizontal component. Then we just mention there's a Fx. Okay, force for the x-axis. Okay, vertical component means the force for the y-axis. Okay, so from here, this one is an example how we go to find out the angle and also how to find out the Fy and also Fx. Okay, depend the situation. So this one we're using the trigonometry. I think your max is learned already. So example, this one, triangle for ACD. This one is A, this one is C, this one is a D. So this one is a triangle, okay, with perpendicular. So they want to find the data. Okay, they want to find the data. So this one, you want to find the data by using the Fx. Okay, Fx is the adjacent over the pulling force. Or you can say this one is a resultant force. Then we're using the cos. Okay, cos data is the adjacent over the resultant force. So from here, if you want to find the Fx is adjacent. So that means the F cos data. Okay, another situation is the ABC. So ABC, if I want to find the vertical, there's a Fy. So we need to using the sine data. Okay, if you say sine data is the opposite over the resultant force. So that means if you want to find the Fy, then the F sine cos. F sine theta. Okay, this one is a trigonometry you learned before for your mathematics. Okay, another one, simple things. Okay, you can learn from here also can. The line opposite the anchor. Okay, example, if I take this one A, D, C. Okay, so from here, if I want to find Fx, can you see the Fx just beside the data? Okay, so from here they mention the line just opposite the data mean this part. Okay, if I bring the Fy go to this side, so the Fy should be here lah. So the Fy now is opposite the anchor, is it? So when it just opposite the anchor, the equation we need to using sine. Okay, how to create? We take the longest one. Always mention the longest one. Okay, now I want to find Fy. So that means Fy equal F. The triangle, the longest one is a F. So you take F. Okay, now Fx is this one Fy. Fy is opposite the anchor. So opposite the anchor, we're using sine. So from here, we can create the equation. If you want to find the Fy equal F sine theta. Okay, how about the Fx? Okay, if you say the Fx just now I mentioned, opposite theta is a sine. So that means beside the angle. Okay, this one just now Fy equal F sine theta. Now it's a beside the angle. The line is beside the theta. Okay, the line is beside the theta is here. There's a Fx. They're just beside the theta. Okay, beside the theta we're using cos. Okay, so now I want to find the Fx. That means you need to using cos. Okay, again, whole triangle, which one is the longest one? It's a F. So I write the F first lah. Then now Fx you need to find, you need to using cos. So from here, the answer should be F cos theta. Okay, so this one is a equation when you find the vertical and also the horizontal component. That means you can using trigonometry. You also can using the concept what you learned before that. Okay, opposite the angle we using sine. Beside the angle we using cos. Okay, so now we go to the next part. Okay, this one is one of the example question. You also can refer your textbook. Okay, now it's a horizontal component and also the vertical component of the pushing force. Okay, now you can see the force pushing downwards and also with the angle 60. So like this, that means we cannot plus straight forward. We need to find out the vertical and also horizontal, or you can say resolution of the forces. Okay, so now the pushing down force is a 32 Newton. So we need to find out what is the horizontal, what's the vertical. So from here, first one we need to draw. Okay, where's the direction? Okay, so from here, this one is pushing down force, 32 Newton. Then the question already provided there's a 60 degrees. Okay, this one is a starting point. So that means I need to draw the two line perpendicular, cover the cover with the pushing force. So from here we find it, we need to draw this one, go to left, then this one is come down. So this one is the original point. So original point, all the arrow must come out from the point. So now this one I label there's a Fx, this one's label is a Fy. Okay, so now we need to find out. Okay, before that I want to test the student. So this one 60 degree. Okay, we normally take the triangle is with the angle. Okay, we normally want to take this part lah, because this one don't have any angle, unless you take this one is a 30. So I take this one is a 60. So from here Fx, can you see the Fx just beside the angle? The line just beside the angle. Okay, remember beside the angle we're using cos. Okay, so when I bring the Fy to come this part, they become one of the straight line. Okay, so after that we find it, this one Fy is opposite. Okay, you can say opposite the angle. So from here we need to using sine. Okay, so now horizontal first. Horizontal is a Fx. So now we go to show. Okay, horizontal component, there's a Fx. So the whole triangle, the longest one is 32. Okay, we just write the 32. After that, Fx is beside the angle, so we take cos 60. So the final answer we get it, there's a 16 Newton. Okay, now we go to the Fy. One using cos, sure another one must be using the sine, is it? So from here we need to show vertical component, there's a Fy. Okay, 32 sine 60. Okay, for the Fx they go to the left, for the Fy they go to the downwards. So the answer for Fy is 27.71 Newton. Okay, this one is the answer for the A. Okay, now we got another situation. They also need to find the component, the magnitude of the component. That means you want to find out what's the number. They do want the direction. So from here, the component of the weight of the boy in the direction parallel to the inclined plane. So you need to find out the component, okay, of the weight. The weight will create the component, because the weight is not a straight line. They just like the anchor, they incline with the anchor. So this one is a plane, okay, inclined plane. After the weight is acting downwards. Okay, remember the weight is always acting downwards. Okay, now they need to find the component of the weight of the boy in the direction parallel with the inclined plane. Parallel, that means they same like this line direction. Okay, so now we need to create the two component from the weight direction. So this one we call resolution again. Now your resolution must from the starting point. This one is the starting point. And also these two lines must be cover the resultant force. So from here we need to draw the perpendicular line. Okay, first one. Okay, this one is the one of the line that's a perpendicular with the inclined plane. Can you see the perpendicular to the inclined plane? Okay, so another one, this one is the another line parallel with the inclined plane. So that means I already create two of the component. Okay, so from here you can find, if I bring this one line, the pink color line to go up, so that means the line, this one we call it as a fx, this one is a fy. Now fx and fy also cover the resultant force, so I bring this one line to come down. So that's why you can see very clear, this one is one of the triangle with perpendicular. Okay, so this one is a 50 degree. Okay, you will ask why you know there's a 50. Okay, later I show you why there's a 50, because here provided is a 50, is it? So from here we go to find out how to find the component first. Okay, so from here they say the weight of the boy is 300. So this one is a direction of the weight of the boy, that's a 300. Okay, now this one is a fy, this one is a fx. So from here the question they want to find is the direction parallel with the inclined plane. So that means they want to find fx. Okay, fx is parallel with the inclined plane. So remember fx. Okay, fx is opposite the angle. Opposite the angle means we need to using sine. Okay, sine. So from here we go to show the line opposite the angle using sine. So from here your equation should be 300 sine 50. That's the fx. Okay, then I show here. Horizontal component fx equal 300 sine 50. So you press your calculator, I get it, 229.81 Newton. Okay, next question they want to find sure is a perpendicular line with the inclined plane. Okay, so what they changes, just perpendicular means they want to find fy. Okay, fy just beside the angle, is it? So from here we still label the line is beside the angle, we call it as a cos. So from here we still to write the longest one. Okay, f is 300. So from here if we want to find the fy, so the equation is a fy equal f. Okay, this one is a f 300, then cos 50. So I get it, that's the answer is a 192.84 Newton. Okay, the question never mentioned about direction, they just want the magnitude. So this one should be the answer. Okay, now we go to the example 3. Okay, example 3 is a mixture of the forces. Okay, now they show about the wooden block being pulled by the force. Okay, this one is pulling by the force, there's a T. There's an incline with the angle 30. So that means later this one T you need to do the resolution. Okay, how about the R and W? R and W we no need to do already because they already is a straight line. Okay, the straight line without any angles. So later we can plus and minus. But the problem now the T is an incline. So you cannot say R plus T. No, that's a different things. So the T later you need to do the resolution, create the vertical and also horizontal. After that, we baru can be joined together. Okay, so now we go and see some the info, the question they give you. Okay, first one, the pulling force, 36 Newton. Okay, then the weight is a 24 Newton. The weight is go downward 24. Okay, normal reaction is a 6 Newton, go up. So that means later you need to convert. One should be positive, another one is a negative. Okay, now one should be the friction. Friction is always we put negative lah. There's a 20 Newton, go to the backwards. Okay, so now the question is, calculate the magnitude of the horizontal component and also vertical component of the pull T. that means the pulling T acting two component, there's a horizontal and vertical. So now you need to calculate. Okay, so from here, we're going to show how to do this question. Okay, we show the drawing first, how the resolution of the fx and fy to produce. Okay, so this part only, the others we do want to see. Okay, first one, this one should be the vertical, because this one is a starting point. So I straightforward go up. If you go down, that means you're wrong. That means you never cover the resultant force. So I draw up. So how about the another horizontal? The horizontal also from the starting point, then go to the right. So now you can see the two line, the component, they are cover the resolution of the forces. Okay, so from here, now we need to create where's the anchor. The anchor should be near with the horizontal. That's a 30 degrees. So this one I just copy from the question. Okay, next I need to label fx and fy. So this one is a fy, this one is a fx. Okay, then we need to do the calculation. Okay, again, fx beside the anchor. Okay, so if you want to find fx, then sure using cos. Okay, if you want to find the fy you bring to this side. Okay, when you bring to this side, you can see the anchor and also the fy is opposite. So when opposite, we need to using sine. Okay, so from here, let me go to create the equation. Horizontal component of the t, that's a fx. So fx is a t cos 30. T is how many? 36. So 36 cos 30. So I get the answer is 31.18 Newton to the right. Okay, but the question now they say magnitude. So if you never mention the direction, it's okay. Okay, 31.18. Then finally they just go to the right. Okay, how about the vertical? Okay, the vertical component, there's a fy. So this one is 36 sine 30. So from here, after you press your calculator, so I get the answer is 18 Newton, then go to the upwards. Okay, so this one is a complete answer lah, if the question asks about magnitude and also direction. Okay, then we continue the same question. Determine the magnitude of that and also direction. So the question they want to mention, magnitude and direction of the resultant force acting on the block. Okay, just now not resultant force. Just now just the component you create. Now finally, I want to know the box where to go. Okay, so from here we find it W is go down, R is go up. So just now after your resolution of the T, you find it the Fy also up, is it? So another one you got Fx. Fx is go to the right. Okay, but the friction is go to the left. So that means later you need to do them plus and minus. Okay, let's see the equation. Okay, we go to the force first. Okay, this one is a Fx. Just now we find it already. Okay, after that we got Fy. Fy is go up. Okay, then we get the readings. This one go to the right is 31.18. Then go to the vertical is 18 Newton. Okay, now we need to find out final resolution. Final resultant force acting to the block. So we need to do the plus and minus. So finally, I want to get net force. Okay, remember the net force. A resultant force, that means after you plus, after you minus, the last one, that one we call resultant force. Okay, so from here we're going to see how to find the resultant force. Okay, for the horizontal part, so that means we just separate by two parts only, horizontal and vertical. Okay, because we already solved the T, the pulling force. We already resolved become the vertical and also horizontal component. So from here we see the horizontal component to the right. Okay, there is 31.18. Okay, to the left, that one is the friction, negative 20 Newton. So finally we need to find out the last one, where they go. Okay, so the last one, resultant of the horizontal component, there's a Fx plus Fr. Okay, now the Fx 31.18. Okay, plus negative 20. Okay, plus minus actually also is a minus lah. So how many you left it? 11.18 Newton. Go to the right. Okay, still go to the right. Okay, now we go to find out the vertical. Okay, the vertical component to the ups, there's a Fy, 18 Newton. Okay, just now we find it, the Fy is 18 Newton. Okay, you also got the weight. The weight is go down. That's a negative 24. So we take up is a positive and down should be the negative direction. Okay, after that you still got one of the normal reaction, is it? Normal reaction is go up. So you put positive. Okay, after that we need to do plus and minus for the vertical component. Okay, so the resultant of the vertical component, there's a Fy plus R plus W. Okay, so Fy plus the R is okay, there's a 24. Then you need to plus and also minus the direction of the weight, they also 24. So that means the resultant vertical component, there's a 0. Okay, they already is balanced. Okay, so that means the box never lift up and never go down. Okay, finally we just got one of the forces acting to the block. What's the force? The force now is 11.18. Go to where? Go to right hand side. Okay, so we go and find out the last answer. This one not answer, this one just calculation only. Okay, the last answer is here. Determine the magnitude and also direction, is it? So this one just now we find out. So finally the direction is go to the right. Okay, so you can see it now, it's a big arrow to move the block. Just now got so many small arrow, is it? Finally we do the calculation, we find it, we just got one of the big forces to pull the block to move. Okay, now the resultant force on the block is how many? 11.18 Newton. Okay, go to the right. Okay, so this one we call it magnitude, this one should be the direction. So this one is the answer, 11.18 Newton to the right. So we got so many steps we need to do out. After that we need to find the last answer. That's a resultant force acting to the block. Okay, so from here, after you find the resultant force, that means finally the block will go to the right. Okay, you need to find out the acceleration if the block mass is 2.4 kg. So we need to find out which one equation we need to follow. Okay, resultant force 11.18 Newton. Another one, the info from the question, there's a block mass 2.4 kg. So we're still using the same equation, F equal ma. So F equal ma means the resultant force is 11.18. Then the mass already provided, so we need to find out the acceleration of the block. So from here, 11.8 over 2.4. So from here, the acceleration is 4.66. Then the unit is a meter per second. Okay, so this one is a continuous question. After you find the component for the vertical and also the horizontal, then you need to find out the overall. Okay, overall resultant force. After resultant force, you need to using F equal ma to find what is the acceleration. So this one is a sequence. Okay, for the question they ask you resultant force. Okay, now we go to the question number 4. They also want to find about the resultant force. Okay, they provided. Then you need to find is the inclined plane. Okay, then you need to resolution. You have to create the two components. There's a vertical and also the horizontal. So from here, they want you to sketch the component of the weight of the block parallel to the inclined plane and also the component of the weight of the block that's a perpendicular. Okay, one means of parallel, one means of perpendicular. So from here, this one is an inclined plane. Okay, this one is an inclined plane. Okay, you can find it. Later you need to resolve two components. One must be perpendicular, so 90 degrees with the inclined plane. Another one you need to draw parallel with the inclined plane. So I now go to show you. Okay, first one I draw, this one is perpendicular to the inclined plane. Is it go downwards because here is the starting point, so I go downwards. So another one should be parallel with the inclined plane. So I draw here because I want to create one of the triangle. If you don't want to draw here, actually you can draw this part. Okay, this one is one of the component that's a parallel with the inclined plane. Okay, so from here we need to label. Okay, the angle should be 60. Later we go to explain why this one angle becomes 60. Okay, then we're going to see the label for the component. This one we call it as a WY. Okay, for this one question they're using W, then we're using W lah. Okay, from here you can see there's a vertical. Okay, this one vertical we label there's a FY. Then this one should be the horizontal, we label there's a FX. Okay, the angle here is a 60. Okay, so now we need to find out why this angle 60. Okay, you can see this one diagram, just now diagram. Okay, now we're going to show another diagram. Okay, if I draw the triangle just now like this, okay, just now it's a 60, is it? Okay, if I one of the straight line, this one is a weight, this one 60, this one should be the 90. Okay, this one is a 90. Okay, so from here this one 90, then understood here is how many? This one is a 30. Because here 60, this one 90, this one sure is 30. Can you see this one also is one of the perpendicular? Okay, we go to draw. Okay, this one also is one of the perpendicular. So if I say here is a 30, okay, this one is a 30. So that means 90 minus 30, understood, this one will become 60. Okay, so we just when a question we never mention anything, they just label here is how many angle. So we understood, we put this part should be the same angle. So this one just one of the explanation why we know this part is same angle like the corner. Okay, so from this one diagram there's a 60, is it? So from here we find it, there's a 60, then another side should be also is a 60. Okay, so from here this one 60 part is here. So after that, because this one is a zigzag, so this one 60 part is here, this one 90, so this one will become 30. So understood, this part will become 60 again. Okay, so this one is a one of the diagram exactly same like just now. We just draw go downwards only. That means you can see very clear. This one data, this one is 90. So understood, this one is 30. So again, this one is 90 degrees. 90 degrees minus 30. So understood, this one become 60 again. So this one is a data. Okay, so we continue to the next calculation. Okay, then you need to determine the resultant force acting to the block. Okay, resultant force. Okay, so from here the info we get from the diagram. Okay, normal reaction is a 12 Newton. Okay, now we got another Fx, then move the block go down. The block don't have any friction because they says move. Okay, another one we know this one is a Fy. Okay, later we compare, oh sorry, this one is Wy. So we compare the Wy and normal reaction because both is up and also down. Okay, Fx. Fx we just got one only, horizontal, we don't have others. So that means we need to find the Fx is how many, and also what is the Wy is how many, and also Wx is how many. So we still using this one. Okay, now you see the angle 60. Wy is beside the angle, is it? So Wy we need to using cos. Okay, when I bring the Wx go to downwards part, this one Wx, you find it the Wx is opposite the angle. So we're using sine 60. Okay, then this one is W. W is go downwards with 24 Newton. Okay, now let's see the calculation. Wx 24 sine 60. 24 sine 60 because this one is the longest one. Okay, we get it 20.78 Newton. Okay, how about the Wy? Wy is beside the angle, so we're using cos. 24 cos 60, then we get it 12 Newton. Okay, now the question they want resultant force. This one not resultant force. This one just a component from the resolution. Okay, so now we need to find out the resultant force. Okay, resultant force for vertical component, there's a 0. Agree or not? Because normal reaction is up, then your weight is go down, should be negative. So from here, 12 plus negative 12, so I get it 0 Newton. So we don't have any vertical force already. Okay, that means we just got horizontal. Okay, now the horizontal, we just left one only, there's a WX. So that means the resultant force on the block, just WX, there's a 20.78 Newton. Okay, we just got one of the forces to pull the box to come down. So that means finally the box should come down lah, because we got one of the force to pull it. Okay, then the question again, they ask about acceleration. How fast the block to move. So this one is the final forces to pull the box to come down. That's how many? There's a 20.78 Newton. Just now we find already. Then the mass of the block is 2.4. So we're using what formula? F equal ma to find what is the A. Okay, so from here, let's see the A. Okay, A is 20.78 over 2.4. So we get the answer, there's a 8.66 ms negative 2. So that one is the acceleration of the block when it's just pulling by the resultant force 20.78 Newton. Okay, so that means I already explained about the resolution of the forces of the two components. So hopefully you understand how we go to resolve. Okay, sure, two of the forces is cover. Okay, cover the resultant force. Okay, resultant force means the whole triangle, the longest line. Okay, the one we call it as a resultant force. So from here, you need to solve your problem from the textbook. That one is a formative practice. Okay, 1.2. So we got I don't know how many questions, so many. So that means you need to finish all, not just question 1 only. Okay, after that, here you can see one of the big of the website. Okay, this one website, that means I want you to download. Okay, you type this one website. After that, you need to download the exercise. Okay, some of the exercise for the resolution. Okay, after that you download, you print out, then you solve it. So that means these two things I will discuss from the next lesson. Okay, so that means hopefully you understand what I mentioned. Then after that, you need to understand, then you need to solve the problem. If not, we cannot do anything. Okay, all the questions from this website is related with the resolution of the forces. Okay, for the student, when you do the formative or the practice, you need to copy the question and also answer it. So that means these two I will discuss from the next lesson. Okay, so hopefully the student, you like my channel and you like my video. So you go to click subscribe for my channel. You just search my name, there's a KSSM in the YouTube channel. Then after that, you can find out my whole video, because I got so many video about the physics and also the science there. So you can refer, do some revision from my video clip. Okay, so my lesson just until here lah. So that's a thank you for your watching. So hopefully you like it and you share to your friends and help your friends about the funny of the physics. Okay, just thank you. Bye.